So we have done the preparations of alkyl halide, aryl halide, reactions of alkyl halide, like a nucleophilic substitution reaction, elimination reaction, right? Now the next reaction is a reaction of alkyl halide with metals. So whenever your alkyl halide, when it reacts with metal like magnesium, okay, it will give a compound having formula MgX, where your alkyl group have direct bond with magnesium, which is a metal, right? Now this reagent is what called Grignard reagent. Grignard reagent, and this one is like organometallic compound. Organometallic compound. Okay, why? Because here the compound, your bond is between your metal and your carbon, so the organometallic compound. Okay, now the preparation, see the preparations of alkyl halide. Okay, preparations of your Grignard reagent from alkyl halide with magnesium. Okay, the reaction will take place in dry ether. Now here this dry condition is very important, so this has to be maintained, right? Why? Because of presence of moisture. Okay, moisture, like if we have like RMGX, if moisture, so if the ether is not dry, if it contains certain moisture, then what happen is like your this Grignard reagent will decompose to the corresponding halide. Okay, now what is corresponding halide? Just timra MgX, okay, will get replaced by H, so you will get is RH, which is hydrocarbon, and this one as byproduct. Okay, now not only water, but any solvent which are a source of proton, okay, like alcohol, amines. So these presence of these also, when this react with alcohol, amines, which are the sources of proton, then in this reactant, with this reactant also, so this okay, Grignard reagent will give corresponding hydrocarbons. Now next is Urch reaction. So reactions of reactions of your alkyl halide with metal, Urch reactions we have done. Okay, so Urch reaction, what is the reactions? So we have already done. So when your alkyl halide, when it reacts with sodium, right, in again dry condition, dry ether, then what happen is like we'll get is alkane, okay, with double number of carbon atom. We have done this. Then phytic reaction is there, so that also is the reactions of halide with metals. Okay, so the main importance with this Grignard reagent is very important, as because this is useful in getting some compounds, okay, preparations of compounds that we are going to do in the next chapter. So but you need to know the formula, which is RMGX, and yes, and in presence of moisture, okay, so this one will get converted into corresponding halide, okay, sorry, corresponding हाइड्रोकार्बन जस्ट तिम्रो अल्काइल ग्रुप जुन चाहिँ RgMgX को अल्काइल ग्रुपमा what will add हाइड्रोजन प्रोटोन एड हुन्छ and you will get is corresponding hydrocarbon. Now next is reactions of haloarenes. Okay, so this haloarene, usually they like undergo nucleophilic substitution reaction with difficulty, and what are the regions, so that we are going to do when we do the question like account the following reasoning type questions. Jab garcha we'll discuss like why haloarenes, okay, will not undergo nucleophilic substitution reaction easily. So only in under drastic conditions, okay, the nucleophilic substitution reaction will occur. So here what we are going to discuss is like electrophilic substitution reaction. So timro electrophile ma ke huncha, electrophile will add in your benzene ring or your haloarene. So suppose halogenation, so halogenation ma, if this is your, okay, chlorobenzene, if we are doing halogenation, so halogenation ma we'll use is, okay, so chlorine and FeCl3 dark reaction, then what happen is like this halogen will add up, halogen electrophile Cl plus will add up to your benzene ring. Now at what position your electrophile will add will decided by the group which is already there in the benzene ring. So what is there in the benzene ring? Chloride, and this is your ortho and para directing group. So that means what you are going to get, so here you will get the isomer, okay, para isomer and ortho isomer. So this is the product that which we are going to get, okay, para and your ortho isomer. Now next is nitration. So nitration ma again, so if this is your haloadenine bromo benzene, okay, nitration garda we use is like concentrated H2SO4, depend garsa whether to use concentrated or dilute, okay. So depends on your this derivative of benzene. So concentrated nitric acid, then what happens is here, okay, nitro group will add up to the benzene ring, and to what position this nitro group will add will decided by bromine. Again this is para and ortho, okay, all halogens are ortho para directing group. So we'll get is ortho isomer and para isomer, Br NO2 plus Br at para position NO2. Okay, so 1 bromo 2 nitrobenzene, 1 bromo 4 nitrobenzene. So this is nitration. Now next is sulfonation. Okay, sulfonation means your sulfonic group will add up to the benzene ring. So again, if this is the chloro, okay, benzene, then sulfonation we usually treat it with sulfuric acid, okay, and we'll heat it. Then what happen is like SO3H group will add up to your benzene ring. Now which position? Again ortho and para. Then last is Friedel-Crafts, which we have already done. Friedel-Crafts alkylation, Friedel-Crafts acylation. So chlorobenzene, if we do alkylation Cl, okay, reagent, your anhydrous aluminium chloride, then what happened? Your alkyl group will add up to the benzene at ortho position and para position. Why? Because chloro is ortho para directing group, okay. Again, so if we do the acylation, so acylation we'll use this acyl group, okay. Then again anhydrous aluminium chloride, then this acyl group will add up to the benzene ring where at para and ortho position Cl, okay, COCH3 plus benzene ring Cl at para position COCH3. These are the isomer during Friedel-Crafts reaction. Now let us discuss some important questions, okay. So this based on your first video, previous video and this video. So whenever HBr the reaction is with your alkene and HBr in presence of peroxide, that means in this case anti-Markovnikov rules is followed, right? Now these are the double bond where the additions will take place. Now according to anti-Markovnikov rules, your hydrogen will go to that carbon which contain less number of hydrogen. So यहाँ कति रहेछ? So to this carbon 1 hydrogen and to this carbon there is 2 hydrogen. So obviously your H will go to this carbon. So what is the product that you are going to get? Okay, यहाँ एउटा hydrogen थियो, one phenyl ring was there, right? And again one hydrogen आउँछ. Now to this carbon there were like 2 hydrogen, one Br will add. So this is the product that we are going to get. Now next is like HCl and alkene again. So this is your addition of HCl to double bond, okay, but this will follow anti-Markovnikov rule because this is taking in absence of peroxide, right? So okay, so यहाँ के छ तिम्रो, these are the double bond where the addition reaction take place. So एउटा hydrogen हुन्छ and in this case there will be 2 hydrogen. So anti-Markovnikov rule, again this carbon will be preferred, okay. So we'll get is like this is CH3, okay, CH2 and a CH3, okay, I'll draw like this, okay. Then to this carbon Cl will add and here hydrogen. So this is the product that you are going to get. 1 2 3 4, so 2 chlorobutane, okay. Now this is your thionyl chloride, so OH group is there. So this is like preparations of halide, right? OH will get replaced by Cl, so you are going to get is like cyclohexane and Cl, okay. Now bromine, and you are doing halogenation using sunlight. So that means here like hydrogen will get substituted by halogen. Now the number of product will depend upon like how many type of carbon are present. Just CH2 एउटा भयो र CH3 अर्को type को भयो. So we'll get two isomer. Benzene ring like NO2, there will be no change, it will remain as it is. Then we'll have like CH first carbon को hydrogen replace गर्छ. We'll get this one isomer and अर्को isomer मा के हुन्छ यहाँको hydrogen will get replaced. So we'll get is benzene ring and O2 and CH2, CH2 and Br. So this is simply like free radical halogenation reaction. Okay. Now next here again HCl sanga, so we are heating this with HCl, so passing your alcohol through HCl, hot HCl, what happen is like alkyl co, okay, OH will get replaced by Cl, and phenolic OH like there will be no change. So phenolic OH will remain as it is, but CH2 co OH will get replaced by Cl. So this is the product that we are going to get when we do this reaction. Okay, now again HI is being added to this double bond. So again we need to check whether Markovnikov rule or anti-Markovnikov's rules followed, right? So there's no peroxide, right? So here again Markovnikov rule is followed. So for that you need to know like this double bonded carbon atom, which one will have large number of hydrogen, right? So यो carbon ma एउटा छ, यो carbon ma 0 छ, right? So that means your hydrogen will go to this carbon. So what is the product then? We'll get like the hydrogen already methyl group is here, and again I will add to this carbon atom. Now next is again bromine, and like heating we are doing, right? UV light. Now again for this like this is your halogenation, so free radical halogenation. For this again you need to know how many type of carbon atom are present, right? So we just divide this into two equal, right? So this carbon and this carbon एउटा भयो, this two carbon, these are different, right? So that means again in this case you will get two isomer. So एउटा isomer मा जस्तै A को hydrogen will get replaced by bromine, and in another so like B को okay carbon एउटा कुनै एउटा को hydrogen will get replaced by Br. Okay, sir. Now next this one RX. So RX then sodium ether. Sodium ether means this is like your Ursch reaction. Okay, so Ursch reaction ma, so whenever you do the Ursch reaction, so what you'll get is you'll get alkane, right, with double number of alkyl group. So double number of carbon atom, हैन? So double number हुन्छ. So just what you do is whatever product you are getting, right? So divide that it in two equal half, and each half represent that alkyl group. Where each half represent alkyl group of your halide. भनेपछि यहाँ if you divide this into two, so this is your R. So R भनेको के हो तिम्रो? This one is your R and X. So all यता CH3, CH3, CH3 छ, okay, and this is X. So when you react your halide with magnesium, what you are going to get? Yes, Grignard reagent, right? So Grignard reagent ma whatever alkyl group cha ra halogen, okay, bichma ko auncha Mg auncha, then X. And when you react it with water, so we have already done like a trace amount of your moisture also decompose your Grignard reagent and gives corresponding halide. So corresponding halide dinu ko lagi your MgX को replace ma hydrogen will come. So the product is CH3, CH3, CH3 and H. So this is the product. Okay, this one is your B, this one is your A, and R is your this one. Okay, sir? Okay. So thank you all. See you in next video.